We're going to be discussing expanding double brackets. And since double brackets are one of the main concepts you need to be able to work on remarkable identities, we are going to do one example of expanding double brackets and then three examples of remarkable identities. Each example will be referring to each remarkable identity. And in regards to the remarkable identities, we are going to go over each one in two methods, either using the double brackets method seen in the first example, or just using the quick way with applying the formula which is required for the remarkable identities. All right, for the first one, we have x minus 7 to x plus 3. This is just purely expanding using double brackets. You have to keep in mind the rule of first with first, first with second, and then after you're done with that, you do first with second with first, second with second. And as soon as we start this, you would see that we're going to start with x times 2x. So it would be 2x times x. And then after you're done with that, you take the 7, you leave that for later. You're done with your first step of expanding, you go to your next one, which is going to be plus 3 times x. As soon as you're done with this, you go to your minus 7. Now notice 7 has a minus in front of it. That minus goes wherever the 7 goes. So it's going to be minus 7 times x, and it's going to be minus 7 times 3. Quick correction, that is minus 7 times 2x. Now we just start with our expanding of basically combining the terms. We've done the expanding procedure which is required. You just now have to glue the terms to each other. 2x times x is 2x squared. And after that we have 3 times x, which is just 3x. After that we have 7 times 2 to give us minus 14x. And last one is just a calculation of 7 times 3, which is 21. The continuation would just require you to join the like terms. The only like terms we have are 3x and 14x. So we combine those like terms. This will give us 2x squared. 3 minus 14 gives us a minus 11x minus 21. This is our first expanding completed. Now to start with the remarkable identities. This is our first remarkable identity. First, we're going to do it using the double brackets method. Keep in mind, this is a power 2. A power 2 means the same thing just exists as a duplicate. So we can write it using two parentheses in this method. And now we start with just expanding first with first, first with second, and so on, just like we did in the first example. Now we start 2x times 2x is going to give us 4x squared. Next, 2x times 5 gives me 10x. Once again, we go to our second term in our first parentheses, that is 5 times 2x, which is 10x, and then we have 5 times 5, which is 25. Our expanding is complete. We just need to combine like terms, which in this case are the 10x and 10x. Always keep in mind when we're doing identities, our like terms are going to be the same number with the same letter. The only things that will change are the signs. So either you'd have positives in front of them or negatives, or one positive, one negative, and we will see those in each case of the identities. 10x plus 10x is 20x plus 25. Our work is done. We can't do anything else just because there are no like terms. Now, if we were to do this the quick way using just the formula, it would be of the structure. Keep in mind the identity has the structure a plus b squared. The direct application of it would be a squared plus 2ab plus b squared. And if I were to apply this in that way, it would be 2x plus 5 squared gives me a direct answer of a squared. A is 2x. So it would be 2x all squared. I'm going to do this in steps. It would be 2x all squared. And then we go to our next part. 2 times 2x times 5. This is 2 times a times b. And then b squared, which is our 5. So 5 squared. This is now going to give us 4x squared plus 2 times 2 is 4 times 5 is 20x plus 25, and that is a direct answer just like we have in the first part. We're going to apply this same concept later as well for the other identities. This is our next identity. Once again, we're going to do it the long way. We first write it as duplicates because we need to make sure that we have it correctly written so that we can expand using the long method. So this is going to be x times x, which is x squared. X times minus 7x, minus 7 times x, minus 7x, minus 7 times minus 7, plus 49. And we now have to add the like terms, add or subtract, depends on the case. In this case, they're both negative, so we combine by addition. So this is x squared minus 14x plus 49. This is it done using the long method. If we were to directly apply the identity in this case being a minus b squared, which should look like a squared minus 2ab plus b squared. The identity would be applied on the exact example. We will take a squared, x is a, so we square it. Now we do minus 2ab minus 2, and then a is x, and b is 7. And then we have to take our b, which is our 7, and we square that as well. We now end up with x squared minus 2 times 7 is 14x, plus 7 squared is plus 49. This gave us the exact same answer as well. Now for our last example, this is, once again, we'll be using expanding double brackets. So let's go ahead and apply it. It's going to be, once again, first times first. So 2x times 2x, it would be 4x squared. That step is complete. Now 2x times minus 1, which is minus 2x. Now we go to our next part. 1 times 2x, this is plus 2x. And then after that, we do 1 times minus 1, which is minus 1. Now, in this identity, something interesting goes on. Notice these two items. It is minus 2x plus 2x. So what's going to happen is, once I add like terms, they are going to disappear. I will only end up with 4x squared minus 1, and that is my final answer. Now, we're going to do this in the quick way as well. We're going to do a minus b, a plus b. This is the general structure of this identity. We are going to show it ends up directly being a squared minus b squared. And now we apply it to the specific question we were using, which is 2x plus 1, 2x minus 1. And this gives me 2x times 2x. This is 4x squared. And then 1 times minus 1 is minus 1. A is the 2x, A was the 2x, and B was the 1. And this is it in regards to dealing with the remarkable identities.